All right, so here we're looking at section 2.2, which we talk about linear relations in two different types of forms, standard form and slope-intercept form. Okay, so I have already filled some stuff in here so that the video's not as long, but let's take a look at this first section, linear relations. So we've talked about what a relation means when we're talking about relations. They're just, sets of coordinate points. And when we talk about a relation that has all of their points lie along a straight line in the graph, that's what we call linear. Okay, so the term linear is referring to a perfectly straight line. Okay, linear relations can be represented by an equation. For example, the equation of this graph can be written as x plus y is equal to 8. Okay, and this is x plus y is equal to 8 is in the form that we call standard form. Okay, so standard form, this is just one way to write linear relations or linear functions. Okay, and it comes in this form, ax plus by is equal to c. So we have x here with the coefficient, y here with the coefficient, they're being added together, and then all of our constants, so the numbers without variables, are on the right side. Okay, and there are some important things to note about this. A, B, and C are integers. Okay, so we have already taken a look at what integers mean. Okay, A is greater than or equal to 1, and the GCF of A, B, and C is 1. So that means if we look at these coefficients A, B, and C, they're basically the GCF is 1, meaning there's no number that each of these can be divisible by. So if we have something like 4x plus 2y is equal to 6, the greatest common factor between our A, which is 4, our B, which is 2, and our C, which is 6, is 2. So if we can divide each of these numbers by 2, then it would be 2x plus y is equal to 3. Okay, and now since there's no number that each of these are divisible by, so this is actually the function written in standard form. Not this first one, because the GCF is not 1. Here, after we divided each one by 2, now our GCF is 1. The only number that all three of these coefficients can be divided by is 1. Okay, so hopefully that makes sense there. Those are the main stipulations of a function in standard form, which is important to note because that's going to be one of your writing prompts. We're talking about standard form. The other thing I want to point out is that the exponents on x and y are both 1. Okay, so we don't have any x squareds or y squareds or any other exponents. Okay, so they're both 1, and we don't write them out when they're 1. Okay, so this first section here is we're being asked to write each equation in standard form. Okay, so those are our directions for these first 6 problems, so that's what we're going to do. So we need to make sure that A, B, and C are integers, -5, 6, and -12. Those are all integers, so we check that. And is the greatest common factor between A, B, and C 1? And yes, it is. There's no number that all three of these are divisible by other than 1. And then we just need to make sure that our AX term is being added to our BY term, and that our C term is on the other side of the equation, and it is. So this is actually our, there's one more thing. Sorry. A has to be greater than or equal to 1 in order to be in standard form. And our A here is -5. -5 is not greater than or equal to 1. So what we have to do to get to make this greater than or equal to 1, since it's -5, we can just multiply the entire equation by -1. So that will change the sign of everything, right? So we're multiplying both sides by -1. So this will be now positive 5x minus 6y is equal to positive 12. Now this is in standard form. Okay, so make sure you're looking at your checklist here. A, B, and C are integers. A is greater than or equal to 1, and the GCF is 1. Okay. Looking at number 2, so we have x and y are on different sides, so we need to get x on the same side. So let's subtract 2x here, subtract 2x. I'm going to keep the x term in front, so we have negative 2x plus y is equal to -9. And then we just need to make sure our a is positive, so we can multiply each term by -1, or we can say we're dividing each term by -1, and we get the same result, and it will be 2x minus y is equal to 9. And there's standard form there. Okay, so it looks like we have A, B, and C are all integers. However, we do have our C term on this left side, so we need to get it on the right side, and the way that we can do that is just by adding 24. We have 9x plus 6y is equal to 24. So they're all integers. A is greater than or equal to 1. GCF of A, B, and C is 1. That's not true because we can divide each of these terms by 3. So let's do that. Then we get 3x plus 2y is equal to 8. And there we have our standard form. So here, let's get this x term on the left side. So we have 7x plus 7y is equal to 7. A, B, and C are all integers. A is greater than or equal to 1. But our GCF is not 1. We can divide each of these terms by 7. And then we're left with x plus y is equal to 1. And there's our standard form there. Number 5, we have x and y on one side, 1 on the other side. And however, our a is not greater than or equal to 1. So what we need to do here is we need to, and they're not integers either, right? So 3/4 and 1/3, these are not integers. So this is important to remember what an integer is. It's all integers are our counting numbers, our natural numbers, counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, plus 0, plus their opposites. So -3, -2, -1, 0, 1, 2, 3, and everything that fits that pattern. So fractions are not considered integers. So what we need to do is we need to make both of these integers. And since they're different, they're different denominators, what we're going to do is we're going to multiply them by their least common multiple. Okay, so it'd be the same number that we would use if we were trying to find a common denominator, which is 12. So we're going to multiply the entire equation by 12. So if we multiply this, let's write it in a different way. Let's say we're multiplying this one by 12, we're multiplying this one by 12, or multiplying this one by 12. When you're multiplying a whole number times a fraction, remember you just multiply the number times the numerator, and then you keep the denominator the same. Or you can think of it as 12 over 1, and then you multiply the numerator times the numerator, denominator times the denominator. So 12 times 3 is 36 over 4, okay? Minus 12 times 1 is 12 over 3y, and then we have 12 over here. Now we just need to simplify these, and we picked 12 on purpose because these will both simplify to whole numbers. 36 divided by 4 is 9x, minus 12 divided by 3 is 4y, and that's equal to 12. So we have our x and y on one side, our constants on the other. A, B, and C are all integers. A is greater than or equal to 1, and the GCF of all three coefficients is 1. So that is our standard form there. Okay, and we have another fraction here. So a, b, and c are not all integers. So we need to fix this. And since we only have one fraction here, we can actually just multiply everything by the denominator, which is 6, and that will get rid of the fraction. So if we multiply this first part by 6, 6 times 1/6 is 1. And that's 1x. And we actually don't even need to write the 1, so I'm going to erase it here. And then we need to multiply each other term by 6, so then we have 6y minus 12. Okay, let's get the y on the same side as the x. We have x minus 6y is equal to 12. A, b, and c, we have 1, -6, and 12. Those are all integers. A is greater than or equal to 1. And the GCF of 1, -6, and 12 is 1. We can't divide it by any number, any other number, so that is our final answer in standard form. Okay, so let's look at slope-intercept form. Here we have slope-intercept form is y equals mx plus b. Okay, so this is probably the form that you remember or that you've heard the most, mx plus b, where m is the slope and b is the y-intercept. Okay, if we were to write this in function notation, it would be, instead of y, we would just write f of x is equal to mx plus b. Okay, and if we take a look at slope, slope is the constant rate of change between points. Okay, so we've all heard this rise over run. Okay, and we'll look at that in a little bit more depth in the next section. There are 4 types of slope. Okay, and we're going to sketch them below. So I've already labeled them out. We have a positive slope, negative slope, zero slope, and undefined slope. And positive slope looks like if you're going, so this is from left to right, we're going to be increasing. Okay, and when I say left to right, I'm talking about the x values. So starting from left to right, our y values are getting bigger. So this is what positive slope looks like. Negative slope, if we are going from left to right, we're going to be decreasing. Okay, and so that means that we start over here and we go down. That's a negative slope. Zero slope is where we have a horizontal line. Okay, so we have no change in y values ever. And so this is horizontal line. And then an undefined slope is where we have an up and down, a vertical line. Okay, and this slope is undefined. Our y's are constantly changing, but we don't have any change in x. And so we say that the slope is undefined because it is straight up and down. Okay, so 7, 8, 9, and 10, our directions here are to write the equation in slope-intercept form, then graph the line. Okay, so for slope-intercept form, we need to identify our m, which is the slope, and then we need to identify our b, which is the y-intercept. Okay, so this is, looks like this is already in slope-intercept form. So there's not as many requirements for the slope-intercept form as there was for standard form. Really, you just need a coefficient to the x. It can be any number, positive, negative, fraction, whatever. And then you need to be adding or subtracting just a constant number, which is going to be your intercept. Okay, so this is already in slope-intercept form, which is great. Okay, the way that we can plot this line, okay, so I like to start with the y-intercept, okay, and the y-intercept is where we cross the y-axis. So the y-intercept here is 7, so if we go up 1, 2, 3, 4, 5, 6, 7, that's this point right here. And then our slope is saying that we're going up to, the rise is 2, and over 5. The run is 5. So we're going up 2 and over 5. Okay, so I can't really go up 2 here because it is gonna go off the graph. So if we want to go down 2, that means we go to the left 5, and that's what I'm going to do here. So I'm going to go down 1, 2, and then over 1, 2, 3, 4, 5. There's another point. This is a straight line because we know this is linear, and so we're just going to connect these dots here and then extend them a little bit past. Okay, so graph the intercept first and then use the rise over run to graph your second point, and then you just connect them and extend the line. So number 8, this is also written in slope-intercept form. Our slope is the coefficient on the x, which is -1, and our intercept is +2. Okay, so that means on the y-axis, we have a point at +2, and then our slope is -1, which means, so if we were to look at this as a fraction, it's -1 over 1. Okay, so that means we go down 1 and over to the right 1. Okay, so if we go down 1 over to the right 1, this is our next point, and then we can just connect these and extend the line a little bit. Make sure you're always putting arrows on the end to indicate that we're doing this forever. Okay, so here we have a function that is not in slope-intercept form. This is in standard form. Okay, so we want to basically solve for y first, and that will give us our slope-intercept form. So to solve for y, we need to subtract x on both sides. So we get 3y is equal to, I'm going to put the negative x first, and then -15. And then we need to divide each term by 3. So we get y is equal to -1/3 x minus 5. Now we have our slope and our y-intercept. Okay, so our y-intercept means is -5. So on the y-axis we go down, we go to -5, 1, 2, 3, 4, 5. Point here, and then our slope is -1 over 3. So that means we go down 1 and to the right 3. Okay, so we'll go down 1 over 1, 2, 3. There's our second point, and the graph is going to look something like that. All right, and then last one in this section, this is also in standard form, so we need to solve for y first. So let's add this constant. Sorry, this is not in standard form. Let's add this constant to both sides. So we have 4x plus y is equal to 1. Let's subtract 4x to get y by itself. We get y is equal to -4x. I'm going to write the x first, plus 1. So we have our slope, -4, and our y-intercept is 1. So +1 on the y-axis is our first point. -4, we can look at this as a fraction over 1. So that means we go down 4 and to the right 1. Okay, so we go down 4, 1, 2, 3, 4, and to the right 1. We'll connect these here and just keep extending this way. All right, so there's graphing from slope-intercept form. Let's look at vertical and horizontal lines, sorry. Vertical and horizontal lines are pretty much straightforward. They're really easy. If you have a vertical line, which we have here, your equation is just going to be, so you can see that at x is equal to -3, so x is only ever equal to -3. So vertical lines are always going to be x equals, and here it's going to be x equals -3. This is the entire equation. X is equal to -3, right? It doesn't matter what y is equal to. For all y's, x is equal to -3. And that's it. For horizontal lines, these are always going to be y equals, okay? But y is never going to change. As you can see, y is always at +1 here. So y is equal to 1. That's the equation for this line. Okay, and as a reminder, this is an undefined slope, and this is no slope, or zero slope, sorry. Same thing, but zero slope. That's what we had in the notes. All right, so parallel versus perpendicular lines. the slopes of parallel. So when you're looking at parallel and perpendicular lines, what we're looking at is comparing the slopes. So the slopes of parallel lines are equal to each other. So we have the same value for the slope. Slopes of perpendicular lines are the negative reciprocal. Okay, reciprocal is kind of a big word, but you should have heard this plenty by now. Reciprocal means like if we're talking about a fraction, so if we're talking about 2/3, the reciprocal is just flipping it, so 3/2. Okay, so if we have the slope and we want to find the slope of the perpendicular line, we need to take the reciprocal, so flip the top and the bottom, and then we want to make it negative. If it's already negative, then we make it positive. So it's just kind of the opposite sign, and then we flip the numerator and denominator. Okay, if you have a number that's not already written in a fraction, remember you can write any number in a fraction. So if you have something like 2, the reciprocal of 2 is 1/2, right? Because 2 it can be written as 2/1. We take the reciprocal, we flip the top and the bottom, we get 1/2. And then remember to find the negative reciprocal, we're just going to make that negative. Okay, so just a reminder on reciprocal there. Let's look at number 13. Directions are determine whether the pair of lines are parallel, perpendicular, or neither. So that means that we need to be looking at the slopes of the lines. So let's find out what the slopes are. The easiest way to find the slope of a linear line is to write it as a y equals equation, so solve for y. And then the slope is just the coefficient of the x. Okay, so we have 10x plus 5y is equal to 5. Let's solve for y. So let's subtract 10x from both sides. We get 5y is equal to negative 10x plus 5. And then we're going to divide each term by 5 here to get y by itself. Y is equal to negative 2x plus 1. Okay, and then your slope here, m, is just equal to this coefficient, which is negative 2. Okay, so now we're going to compare this with the slope of the other equation and see if they are equal, if they're negative reciprocals, or if they don't have any kind of relationship. Okay, so here we want to solve for y. So let's add x to both sides. Then we get 0 is equal to 2y plus x plus 16. Let's subtract 2y from both sides. We get negative 2y is equal to x plus 16, and then divide each by negative 2. Then we get y is equal to negative 1/2 x minus 8. And then our m here is just this coefficient, so m is negative 1/2. Okay, so now we're comparing m is equal to negative 2 and m is equal to negative 1/2. Are these equal? No, they're not equal, so that means they're not parallel. Are these opposite reciprocals? Well, what is the reciprocal of 2? 1/2, okay? And then the opposite, or the negative of a negative, is positive, but this one is still negative. Okay, so we actually don't have the opposite. So your perpendicular lines are always going to be one's negative and one's positive. But these are both negative, so that means that these are neither parallel nor perpendicular. Okay, so the answer here is neither. Let's look at number 14. So we want to solve for y again so that we can easily see what our slope is. So let's subtract 8x from both sides. We get negative 6y is equal to negative 8x plus 42. Divide by negative 6 each term. We get y is equal to, well, this will be a positive 8/6 can be reduced to 4/3. For positive 4/3 x, this is going to be minus 7. So our m here is positive 4/3. Let's look at our other equation. We already have y on the one side, so let's just divide everything by negative 3 to get y by itself. We have y is equal to negative 3 plus 4/3 x. Okay, so even though the x isn't first, it's fine that we still have the slope is still positive 4/3. Okay, so we have m from the first one is 4/3, m from the second one is 4/3. They're both positive, they're exact same thing, they're equal, so that these lines are parallel. All right, looking at number 15, same thing here. Let's solve for y. So add 8x to both sides. We have 8y is equal to 8x plus 0, which we don't need to write, and then we'll divide by 8, divide by 8. Y is equal to x. The coefficient on here is 1, right? There's a 1 being multiplied by x always, so our m here is equal to 1. Let's look at our other equation. We have x minus y is equal to 4. Let's subtract x both sides. Negative y is equal to negative x plus 4. Let's divide each term by negative 1 so that we have y by itself. Y is equal to x minus 4. And our m here is also equal to 1. The coefficient there is 1. So we have an m of 1 and an m of 1. Slopes are equal. That means that these are also parallel. And number 16, x is equal to 2 and y is equal to 2. So that means that we have a vertical line here at 2 and a horizontal line at 2. Okay, our slope for the first one for all vertical lines are undefined. And for horizontal lines, so we'll say m is equal to undefined, and then m is equal to 0. Okay, so if we think about parallel lines graphically, they're always going to make a right angle. So if we have a vertical line and a horizontal line, they are always going to make a right angle. These are perpendicular to each other. Even though undefined is not a number, it is going to be parallel to any line that has no slope. So these are actually going to be perpendicular. All right. So that is your first 2 pages of notes. Let's look over at your third page. Okay, so we're going to take a look at x and y intercepts. So let's look at what this says here. The point at which the graph intersects the x-axis is the x-intercept. Okay, so where the graph intersects the x-axis, that's the x-intercept. Okay, and then when you have a point at which the graph intersects the y-axis, that's the y-intercept. Okay, so if we look at this graph here to the right, it asks us to identify the x and y intercept on the graph shown at the right. So if we look for the x-intercept, where does it cross the x-axis? And that's this point right here. And then where does the graph cross the y-intercept? Well, that's this point right here. When you're giving intercepts, you're always going to write them in a coordinate point. So the x-intercept, our x value here is -3 and our y value is 0. So there's the coordinate point for the x-intercept. And the y-intercept, our x is 0 since we're on the y-axis, and our y is 1, 2, 3, 4. Okay, so you're always going to give a coordinate point if you're asked to give the intercept. It's always a point, an x and a y value. Okay, the x-intercept is also referred to as a root, a 0, or a solution. Okay, so these 4 are interchangeable. They mean the same thing. If you're asked for one of them, the forms are a little bit different, right? You always give the x-intercept as a coordinate point, but for root zeros and solutions, you'll give those just as x values, but we'll get into that a little bit later. Okay, so now we're going to look at finding the x and y intercepts algebraically. Okay, to find the x-intercept of an equation, let's see, x-intercept was blue, we are going to set y equal to 0 and solve for x. Okay, so if you look at our x-intercept up here, our y is equal to 0, right? So in an equation, we'll set y equals to 0 and solve for x. Okay, when we are finding y-intercepts, we're going to set x equal to 0 and solve for y. So we're going to do just the opposite. X is 0 here. Okay, so let's do that algebraically. And then, oh, this is an important thing to note too. You can use these points to graph the equation. So just like we had up here, if you have both intercepts, you can just plot those and then you just connect the line in between them and extend it, and that's how you can graph that equation. So find the x and y intercepts of the equation y is equal to negative 2x plus 5. Okay, so to find the x-intercept, it says here we're going to set y equal to 0. So we have y is equal to negative 2x plus 5. We're going to make y 0 and then solve for x. So negative 2x plus 5. Okay, and we all know how to solve linear equations, right? We're going to solve for x, so we're going to subtract 5 from both sides. Negative 5 is equal to negative 2x. Divide by negative 2, divide by negative 2. X is equal to positive 5 halves. Well, let's actually not circle that because we want to write it as a coordinate point. So the x-intercept is actually 5 halves for x, and y is 0. So this is the x-intercept. Okay, and then for the y-intercept, we're going to set x equal to 0. So our equation is y is equal to negative 2x plus 5. Set x equal to 0 and solve for y. So y is equal to negative 2 times 0. We're replacing x with 0. And then solving for y. So negative 2 times 0 is 0. 0 plus 5 is 5. So our coordinate point x is 0, y is 5. There is our y-intercept there. All right. So for the next 1 to 7 problems, our directions are to find the x and y intercept of each equation and then graph it using the intercepts. Okay, so let's look at how to do that. So if we find the x-intercept here, that's where we set y equal to 0. So we'll put 0 in for y. That's equal to 5x minus 1. We'll add 1 to both sides. 1 is equal to 5x divided by 5. X is equal to 1/5. So our coordinate point is x is 1/5, y is 0. There's our x-intercept. Y-intercept, we'll put in 0 for x, so we have y is equal to 5 times 0 minus 1. Y is equal to 5 times 0, 0. 0 minus 1 is negative 1. And so our coordinate point is x is 0, y is negative 1. Okay, so now we're going to use these to graph. So we have this point 1/5, comma 0. So x is 1/5 and y is 0. So let's just say it's going to be right here, pretty close to the origin there, because 1/5 is 0.2. And then we have x is equal to 0, y is equal to negative 1. And so we have this point here. We're just going to connect these and extend them. And that's what the line is going to look like. Well, I guess I could probably extend them a little bit further, but something like that. All right, so for our x-intercept, we're going to set y equal to 0. So where we have y, now we have 0, and then we have negative 6 over 5x plus 2. Solving for x, we'll subtract 2, subtract 2. Negative 2 is equal to negative 6 over 5x. And then we want to get x by itself. So we will multiply this by negative 5 over 6. Multiply by negative 5 over 6. On this right side, negative times negative is a positive. 5 over 6 times 2 is 10 over 6. And then this is equal to x. We'll simplify this a little bit. X is equal to 5/3. So our x-intercept is going to be 5/3, comma 0. Okay, and our y-intercept. Our y-intercept, we're going to set x equal to 0. So we have y is equal to negative 6 over 5 times 0 plus 2. Then we have 0 plus 2, that's equal to 2. So our intercept is going to be x is 0, y is 2, and those are those 2 points. Okay, so on our graph here, our x value is 5/3, and 5/3 is in mixed form is 1 and 2/3. So we're just going to be almost to 2 here on the x-axis. And then our y-intercept is at, it's at +2. Okay, so we're going to have a negative slope here. So it's going to look something like this. Okay, and I'm just extending it. Number 3, finding our x-intercept. We're going to have y equal to 0. So we have 0 is equal to -3x plus 16/3. Solving for x, we're going to subtract 16/3, subtract 16/3. We get -16/3 is equal to -3x. We want to divide both sides by -3. Okay, and if you remember, dividing by -3 is the same thing as multiplying by -1/3. Okay, so we can actually write this as, let's see, let's change the color, multiply by -1/3 and multiply by -1/3. You'll see that this -1/3 and this -3 cancels out to leave us with just x, and then here we have positive 16/9 is equal to x. I don't think we can reduce this one at all, so that is our x value. And our x-intercept we're going to write as 16/9, 0. For our y-intercept, we're going to set x equal to 0. So we have y is equal to -3 times 0 plus 16/3. Then that's equal to 0 plus 16/3. So y is equal to 16/3. We write that as 0, 16/3 for the actual y-intercept. Let's graph these two and make a line. So 16/9, not quite 2 yet, so it'll be 1, and then we would have 5/9 left over. Okay, so something that's pretty close to 2, so I'm just going to make it close-ish to 2. And then for a y-intercept, it's 16/3. That sounds like 5 1/3, so we're going to go 2, 3, 4, 5, just a little bit past 5. Okay, and then we can extend it this way. Okay, so if you want these lines to look a little bit better, you can of course use a ruler or a straight edge to connect the dots and extend them. I'm not doing that on here to save time, but that is a great idea. X-intercept for number 4, we're going to set y equal to 0. So we have 4x minus 0 is equal to 8. So these don't all have to be in slope-intercept form. They can be in whatever form. It's still going to be the same. You're still going to be replacing y with 0 and solving for x. So now we have 4x is equal to 8. We'll divide by 4. X is equal to 2. So that coordinate point is going to be 2, 0. For the y-intercept, we're going to be setting x equal to 0. So we have -5 times 0 minus sorry, that's the wrong one. We are going to have 4 times 0 minus y is equal to 8. We're solving for y. Well, this is 0 minus y is equal to 8, which is -y is equal to 8. We'll divide by -1 to get y by itself. We get y is equal to -8. The coordinate point is 0, -8. Okay, so let's graph these. These are quite a bit easier to graph, no fractions here. Our x-intercept is at 2, 0, which is here. Y-intercept is at 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. This is the last one here. And then we'll connect these 2 points here and extend the line, something like that. Number 5, for x-intercept, we're setting y equal to 0, so -5x minus 4 times 0 is equal to -24. 4 times 0 is 0, so we have 5x is equal to -24. We divide by 5, x is equal to -24 over 24 over 5. That cannot be simplified at all. No, I'm sorry, this is negative. This is negative. So we need to, we can multiply by -1, multiply by -1. X is equal to positive 24 over 5. Or we could have just divided by -5. Okay, anyway, so our coordinate point is 24 over 5 and 0 for y. Our y-intercept, where we set x equal to 0 is -5 times 0 minus 4y is equal to -24. Well, -5 times 0 is 0, so we have -4y is equal to -24. Divided by -4, we get y is equal to 6. Our coordinate point is 0, 6. Okay, let's graph these. So 24 divided by 5, so that's going to give us 4 and 4/5. So almost 5. So our x-intercept is 1, 2, 3, 4, almost 5, 4.8 technically. And then our y-intercept is positive 6. 1, 2, 3, 4, 5, 6. That's here. We'll just use something to make a straight line. And there's our graph. 2 more left here. To find our x-intercept, we are going to set y equal to 0. So we have 3/4 x minus 1/3 times 0 is equal to -2. 0 times -1/3 is 0. So we have 3/4 x is equal to -2. We'll multiply here by 4 over 3 on both sides. To get x by itself, we get x is equal to -8/3. So our coordinate point is -8/3, 0. There's our x-intercept. To find our y-intercept, we're going to set x equal to 0. So we have 3/4 times 0 minus 1/3 y. That's equal to -2. 3/4 times 0 is 0, so we have -1/3 y is equal to -2. We're going to multiply by -3 over 1. To isolate y, we're going to get y is equal to positive 6. So our coordinate point would be 0, 6 here. Let's graph these. So our x-intercept is 8/3. That is going to be 2 and 2/3. So 2 and 2/3 we'll say is about there. And then our y-intercept is positive 6. So 2, 4, 6. Let's just connect these lines here. And there's our graph. Last one here, x-intercept. We'll set y equal to 0, so we have 5/2 x plus 5/6 times 0 is equal to 6. 5/6 times 0 is 0, so we have 5/2 x is equal to 6. We'll multiply both sides by 2/5 to get x by itself. We get x is equal to 12 over 5. Our coordinate point is 12 over 5, 0. There's our x-intercept. And then y-intercept, we'll set x equal to 0. So we have 5/2 times 0 plus 5/6 y is equal to 6. And 5/2 times 0 is 0. Then we have 5 over 6 y is equal to 6. We'll multiply this by 6 over 5. 6 over 5. Then we have y is equal to 36 over 5. Our coordinate point is 0, 36 over 5. Okay, that's our y-intercept. Graphing this now, we have 12/5, which is 2 and 2/5, so 2.4. Mark that right about there. And then 36 over 5, that gives us 36, 7 and 1/5, so 7.2, 2, 4, 6, 7, just past 7, and then we will connect these.